Now, welcome everyone to this seminar about Polyspace for verification and validation. Today, we are going to talk about the topic in this agenda. Firstly, we will have a brief introduction about what static code analysis is about with Polyspace, starting with the motivation, why we think that dynamic test is not enough, and also how does static code analysis works. Yeah, what is the relevance of static code analysis for safety critical devices in the aerospace as well also as in the automotive domain. And also we will explore what are the capabilities Maxwell can offer you in terms of cybersecurity. Yeah. And that is the basic of the workflow. Once you have a mature process, a mature development startup, then you can think about to automate the workflow and then bring up things we call DevOps or workflow integration, where you can then apply what you have done in the first phase of your verification in a continuous integration workflow using, for example, a pipeline. Yeah. And also, once you have this pipeline in place, when you have the result, how can you work on the result? Yeah. And that is where we think that a team-wide review collaboration workflow can be offered to you so that people in the same company, in the same department, or even broader way in other country can share the same dashboard and the same place where the results are stored and then communicate through this platform, then to review and then fix things and then evolve and see how the trend of the different projects are. And by the way, that means also how to share those results across larger teams. Yeah, how larger team can also use our tool to work in collaborative way. So the end, then we will have a session for question and answer that Olga will manage. And during the presentation, if this very important question arise, then please just ask your question, raise your hand, and then ask your question. Otherwise, you can also type your question in the chat. They will take notes, and then at the end of the meeting, then we will answer your question. So let us beginning with our motivation for static code analysis. It's not that dynamic analysis cannot replace static code analysis, the same as static code analysis cannot replace dynamic analysis. That's something we should be clear about at the beginning. So, okay, why dynamic testing is not enough? That is my motivation. Imagine yourself, when we are talking about the code, at the end of the day, we are talking about quality question. So that is the conversation between the engineer and the project manager or the QA department, for example. The developer said, here is your code, it's done. The manager very happy said, great, it is bug and runtime error free. With fully confidence, the developer will say, yes, everything is tested, there's no error. Back to the manager, who will ask you, please prove it to me. How can you prove it that your application is free from runtime error? So to know the quality of your software, the first thing to prove that the code is correct is to test. What is testing? Testing is then to run some execution on your code, make different iteration until at a certain stage, we cannot move forward because for each iteration you could find some error, but because maybe of time constraint, of budget limitation, of release time, you have to stop. What you have achieved is that you have shown that your application is functional, it's working, but you couldn't prove the absence of runtime error in your application. Yeah, that is what it's about. And how this map in the reality is that sometimes we have recall, because as you can see yourself in the news, sometimes you have different big company, they have called the different line of vehicle because some ECU problems like brake or light or something like that. Even the software were tested, developer tested well before it was put into production. Yeah, that's where we say that we have a problem. And our problem is that tests and review aren't exhaustive. Why? Because with program testing, we can show the presence of bug, but never show their absence. That is what testing is. That is what dynamic testing is. And now, on the other hand, how does static code analysis can help you? Yeah, with static code analysis, it can help you to find bugs and security vulnerabilities as well. Helps you to conform to different coding standards like MISRA, or for cybersecurity like CERT-C or common weakness enumeration, or even customize the coding rules. It can also provide you some metric to measure the quality of your application. If it's still testable, if it's good written, if there's enough comment, for example, if the density, the call level, nested function, such things are correct. Yeah. But most importantly, then it can also, you can prove static code analysis, prove the existence and absence of runtime errors, what you cannot do only by doing dynamic tests, for example. Yeah, and most importantly, if you remembered my second slide where you could run different iterations, find some error, but never reach a quality level because you have to stop testing, then applying static code analysis, you can specify and so the way to test so that you can reach the desired quality level. Yeah, we will see it along the presentation. So yes, and then going through all these different bullets at the end of the day, if you perform all those tasks, then you can also perform or comply to the different certification standards, such as the DO 178C or the ISO 26262, or the IEC for the electrical, electronic, or even for the medical domain. Yeah. We will see some exact example, detailed example about the DO standard and the ISO standard later on, how static code analysis can help you to achieve those standards. So now moving to the second part, how does static code analysis works? Yeah, and now I will take a general workflow because all the different standards based on the IEC 61508, and means, for example, the ISO 26262 or the medical or the highway are all derived from it. And if you look close at the standard, depending on the way you are taking, if you are going for handwritten code as shown on the top, or if you are going for model-based design, it doesn't matter. At the end of the day, you will deal with code. And once you have the code, the static code analysis can then apply at this level. And that is where we could use our internal tool, Polyspace Bug Finder and Polyspace Code Prover, verified application. That means again that your Polyspace can act at the model level as well as at the code level. Let us start with the model level. So at the model level, since we are MathWorks, so it means we have our base product, MATLAB and Simulink. Polyspace can be integrated into MATLAB as well as in Simulink. If offer you this seamless integration that can also help you to early verify, find and fix bugs in your application, check for coding guidelines for compliance as well. And also the API is so design that is consistent and that you can also put it in a continuous integration. Yeah. And as I said, also our tools, we don't only show the presence of bug, but we can also prove the absence of runtime error. That's how Polyspace acts at this stage. So it means you can use Polyspace, use MATLAB script to run Polyspace, or you can run Polyspace with integration in the Simulink editor, or even you can run Polyspace on code generation with the MATLAB Coder app. Yeah, you have many possibilities of this kind of integration. And picking up, for example, the integration in the Simulink environment means if you are working in Simulink starting from release 19A, for example, you will have in the Simulink menu bar also a Polyspace menu that will give you some execution button related to Polyspace. Yeah, so it means you don't need to go out of your Simulink RDA to run the Polyspace verification. You will still stay in the same environment with C code generation and then run Polyspace. That's something we will see. So what does that mean? That means before I can run Polyspace, I still need to generate code. And even if I have generated code and I cannot say that my code is completely safe or free from runtime error, because things like, for example, do I have some MISRA violation? Do I have some cybersecurity issue, or do I have some multitasking issues like deadlock or illegal defensive pointer? That's something I need to check at the code level. So means, as usual, at the beginning, I will design my model. From my model, I will generate the code. And from the code, I can also make an integration with low-level code, for example, and then apply static code analysis on it for verification. Yeah. So this means, as with Polyspace, what is some main characteristics that this workflow offers you? You have an easy launch of Polyspace. You have the results show in the Polyspace UI, and you have a description of the violation. In this case, it was a Mistra, and you have, most importantly, you have a link that helps you to trace back to the model. So it means you have a back traceability between model and code and model. Yeah, so it means even if you are a designer that's not so comfortable with code, you can still have some reference and some link that can help you to go back to the model and see the place that is impacted by this error. Let us run one small demo so that you can see exactly what I'm talking about. So as you can see, that's a small Simulink model. The first thing I do is then I will invoke the coder and then build my model to generate the code. Yeah. And then once the code is generated, then I will have a code generation report, as you can see here. And I will now then go back into the Simulink IDE, and then on the menu bar, I will call a menu called verify code, as you can see. Then I will have this Polyspace menu. And from the Polyspace menu, I can add additional setting, means what do I want really to check in this generated code. I can manage data range variable then for input and output, and I can also add additional configuration. Yeah. And then I will click on this button, then I will have the Polyspace menu where I can then, for example, configure for runtime error for defect checks. Yeah, I can select all, for example, and do the same for the coding guideline. I will choose the standard 2012, for example. And then since I have generated the code, I will check this checkbox and then set, for example, if I want all the rules or if I just want a subset of it. Save everything once the setting is done, and then apply it, and then go back into Simulink and then launch the verification by just clicking on selecting between bug finder and code prover first. Yes. And then just run the analysis. You see, until this stage, I'm still in the Simulink environment. I didn't get out of Simulink. Yeah. And I can also call the MATLAB window and then observe in the command line as run log how the verification is going on. At the end of the analysis, so I have the information, I can then switch back in Simulink and then just click on analysis result. And then for the first time, Polyspace UI will be loaded, and then it will show me the result of the analysis of the generated code. Now, as you can see, we have in this result, we have 11 Mistra violation, but no runtime error. And if I click in the result list on one violation, I will jump on the right side, as you can see here, on the part of the code that is violated. Yeah. And here, as you can see, I have the information, this backlink. Clicking on this, then I will then jump back and then see that in Simulink, that is the block that is impacted by this data type conversion. And so I can annotate this block, adding a comment review to it before fixing it. Yeah, that is how the workflow works. More on that later. That's what's just to show you how this integration look like. Yeah. So then to summarize, this is what we call shift left. That means very early verification, where you can analyze codes from model and find defect very early, and then have pre-source result and propagate data range from model, for example. Yeah. And also that's something that can also be done remotely on server and cloud. That's something we will see in the second part of the presentation. Now, switching from code, from model to code, the same can also apply in this handwritten code. Now I have a manual code, and in this manual code, I'm asking myself, is there a bug in this application? Where could be a potential bug? Yeah, quickly look on it. I can suspect that at this line, the line 21, it could be a bug. Why I could have a bug is because on the line 4, as you can see here, I have my variable that is declared as full range and also a signless. That means also a misrevelation. And this can lead to a division by 0. Yeah, so it means we will now consider this operation x divided by x minus, right? And what could be the potential runtime error? We have seen that the variable may not be initialized. And since that is the case, it could also lead to an overflow subtraction on those variables. And most critical, if x is equal, right, then we could have a division by 0. Now, how to prove that runtime error do or do not exist at this line? Yeah. So that means again by applying testing, exhaustive testing, and then now by considering that both variables are from type 32 bits, signed integer, and then making all the possible combination, and we have 4.6 billion test cases to achieve. Now, taking a very good machine, let's say, and then trying to execute those 4 billion test cases and considering each to take only 9 seconds, for example, I will need more than 339,000 years to execute all possible test cases. Means exhaustive testing is not possible. Yeah. So now I will move forward and then show that again, before trying to run static code analysis on it, I will again take the code on the loop, and then we can see that we have at very different stage some variables that are not initialized, as you can see. Additionally to it, using those variables can lead to some potential overflow. Yeah. And also, most critically at this line, as we saw at the beginning, we could have a division by 0, and that's not all because it can also have a detection of dead code at this line. Why? I can quickly tell you, because magnitude is a signed variable, means, and signed variable not initialized, means it could take a random value, and this random value can be negative. And if this is the case, then maybe this card will never execute. Yeah. So we can have a potential dead code at this stage. So, but then if I run Polyspace on this code, then you will see that Polyspace will turn everything green. Yeah. And also show me, especially for the division by 0 operation, that the operation on the right side, the x minus right, is in this interval between minus 214 million something until minus 1. You see 0 is excluded. Means there's no way we could have a division by 0 at this stage. Furthermore, Polyspace were able to find out that for this operation at this line, the value for x is 10. Yeah. And so having those information, Polyspace can also give us the interval where the final result will be. Means it will be between minus 10 and 0. Yeah. So it means we have formally proved that there's no runtime error in the application, and so the application is robust, it's not unsafe under any condition. Yeah. That's 3 minutes before I move forward to explain you that Polyspace use different color scheme. Yeah, we have seen green, also means green. With green, we have an application that the code will not fail under any other runtime condition, because Polyspace consider all the cases, even the worst cases. Yeah. But then if you have a red color means you have a critical runtime error, something that needs to be fixed, yeah, before moving forward. And as logical, because it's a sequential analysis, everything below the red fold will be gray. I mean, that will be a dead code, a unreachable code in this case. Yeah, but there's also some special dead codes, mean because you have any guard condition that doesn't that's not true or false, depending on how the guard is, and the code at this stage will be as dead code. Yeah. Another color is the orange color. With orange color means we have an unproven operation. What does that mean? It means that Polyspace wasn't able to decide whether the operation at this line can turn gray, red, or green. So it's asking for the developer to provide additional information, context information, so that Polyspace can solve it. Yeah. And with purple color in the verification will be always the MISRA violation. Yeah. Even if Polyspace is static code analysis tool, it also provides you some range data tooltip that is very helpful when you are dealing with data and control flow analysis. So means Polyspace is able for each line of execution to give you exactly the interval where the variable execute or operate. Yeah. That's the color scheme for Polyspace. That's just the little bit introduction about static code analysis, how this apply with using our Polyspace tool. Yeah. And talking about Polyspace tool, we have two tools. I have shown you sourcing and proving and bug finding. What is the difference between both? First of all, I will again show you the full landscape of Polyspace. So Polyspace is a static code analysis that's applied on handwritten code, on auto-generated code, or a mix of both. And the language supported are C, C++, or Ada. Yeah. And what method I use? The method used for Polyspace is the formal method based on abstract interpretation. Yeah. And what are the key goal of Polyspace? The key goal is to find runtime errors such as division by zero, overflow, or out of bound of array index, for example, comply to the coding standard like MISRA or cybersecurity with CERT-C, provide you code metrics, and most importantly, prove the absence of error. That is what Polyspace is about. And now that is the Polyspace tool feature and landscape. We start with Bug Finder. What can Bug Finder cover? Bug Finder basically covers three main topics. It provides you code metric, like with his metric, for example, and function metric, for example, and Polyspace Bug Finder helps you also to comply with different coding standards. We support not only the MISRA standard, but also support common weakness enumeration, CERT-C, CERT++, and all these standards are fully and completely 100% supported. As well, or for people working on the Autosar, with Autosar, we also support Autosar C++14. And the third category is regarding the defect and vulnerabilities, where you have the numerical defect like division by zero, a static memory like null pointer, or dynamic memory like dead code, for example, dead condition. We have some programming defect. We have also data flow. And in terms of security, cybersecurity, you have a special category for security, for cryptography, or for tainted data. Yeah. And for multitasking application, we do have also the concurrency defect category. And since Polyspace also supports C++, we have also a very specific object-oriented checks for the C++ language. Yeah. So means applying Polyspace, you could already have a high quality, secure, and compliant code that is measurable, maintainable, and consistent. And then with them, you can then, by the way, obtain some credit for functional safety or even cybersecurity standards. On the other hand, Polyspace code will just focus on a very specific and critical subset. So means for this subset, they are not so much like in Bug Finder, but that's the kind of defect that can also be mathematically be proved. Yeah, taking for example a good practice check in Polyspace Bug Finder. That's the check that helps you to make your code better readable, for example. But that's the kind of defect that will not make your application crash. Everything that can make your application crash, Polyspace code will make sure that will not happen. Yeah. And additionally to that, then Polyspace can also help you to calculate or to measure the stack usage in your application. And the same as with Polyspace Bug Finder, with Code Prover, you have a fully trusted component, means it will make sure that the remaining runtime errors are fixed and that you have a robust application. This is proven free from critical runtime error, and that can also be served as reusable code. Yeah. And also additional credit for the standard can also be obtained using Polyspace Code Prover. So here is a table comparing both tools. So we have, as you can see on the left side, we have Bug Finder. With Bug Finder, we have more than 300 type of defect that can be checked. or with Polyspace Bug Finder. On the other hand, Polyspace code will have only a 30 critical defects that can be checked. Yeah. In terms of analysis, the bug finder analysis is very quick, so comparable, for example, as when you compile your application. And the code prover, because it's a very deep analysis, take more time, it's exhaustive. And in terms of reporting criteria, with bug finder, you can have a probable defect, but in code prover, it can show the presence, but most importantly, prove the absence of runtime error. False positive are possible in bug finder, and in code prover, it's more complex because it depends on the way you have set up your application. It's very context sensitive to say. In terms of false negative, it's possible using Polyspace Bug Finder, but it's not possible in Polyspace Code Prover because the analysis is sound. Yeah. So here again, put in picture is that means on the left Bug Finder and Code Prover, you see if nothing is found in Bug Finder, you will have just the information that nothing is found. But if you have a probable bug, then it will show in red. On the other side, with Code Prover, you have these oranges as explained. You have the green color. You have the gray color for unreachable or dead code, and also for runtime error, you have the red color. And the MISRA coding guideline could be checked with both tools, but starting with release 23B, it will be only present in Polyspace Bug Finder. Yeah. Just to put here for some people who are already using Polyspace that maybe in the past they have used also code for to check for MISRA violation, but for the future will not be the case anymore. So by analogy, we can say that everything that are not found in Bug Finder is everything that is shown green in Polyspace Code Prover. Yeah. So that is the recommended workflow. We recommend you to use Bug Finder frequently, and because it's very fast and doesn't go too deep. And then Code Prover, we recommend you when it's needed, maybe once per week, or to make the component very full trusted and more robust. Yeah, so that means you can use at the end of the verification, maybe once per week in your pipeline or your Jenkins, for example. Yeah, on if we take the V cycle, for example, where could you apply Polyspace Bug Finder and Polyspace Bug Code Prover? In the implementation phase is the phase where we recommend you to start with Bug Finder. Also in the integration phase, because Bug Finder can scale well with very big, large code, and then it can help you to find, for example, declaration mismatch at the different interfaces. Yes, and in software acceptance test, then with Bug Finder, you can have different quality metrics report as well as quality report generation regarding, for example, the coding guideline or the runtime defects, for example. Yes, and in the design phase, we recommend you to use Polyspace Code Prover, which is CP here, as you can see here. And also, before running unit tests, then you recommend you to use Polyspace Code Prover because it can already help you to find untestable function or unused code, for example. And it was also help you to make automatic deviation regarding MISRA coding violations. Yeah, as the same as for Bug Finder, you can also have different type of report and safety artifact report using Polyspace Code Prover. So now, and I will quick jump to another topic because we have many topics. Yeah, and Polyspace in the context of Autosar, for some of you in the automotive who deal with Autosar, Polyspace can also help you to analyze the Autosar software. Yeah, and if you take the Autosar architecture, yeah, where Polyspace can apply, we see that in the application layer, you can use Polyspace to verify your implementation. Yeah, and at this state, then everything related to the RTE will be stopped because it's not automatically verified by this special feature for Polyspace. Yeah, and for the basic software, nothing is verified using the Polyspace for Autosar feature. What can be analyzed using this Polyspace for Autosar? What kind of result can you expect to have? Polyspace will check if all renewable that are defined in your RxML specification are implemented. Yeah, and also it will check if all renewable implementation conform to the data constraint in the RxML specification. Yeah, also the same happen with the RTE function. You make sure that the data constraints are matched the same as in the Autosar specification. Yeah. And then in applying some specific function, you could also, by this type of analysis, find out if there are any overflow, division by zero, etc. in your application. Yeah. How the workflow look like, that is how this Autosar look like. So means basically what you need to provide for the analysis is the XML description, where you have the software component description. You need to have the implementation, mean all the .c, .h file with the macro that belong to that. And applying this Polyspace engine, the Polyspace engine now will read this XML file, get together with the code, then understand how everything is built, then split it in different software components per XML definition. Then each software component analysis will be performed separately using Polyspace, and then you have the synthesis of the result showing in this kind of dashboard, for example. So it means you can run on the command line as well as you can do the same in the Polyspace UI. Yeah. And that is, for example, an example of the bottom approach, meaning you have a back and forward between your XML file. Means from the Autosar authoring tools, you will first import the architecture into Simulink. Then you will implement it. Then after the implementation, you will generate the code, and the XML file will be updated in the second phase. And then with Polyspace will read the updated XML file and then check together with the SVE code if the code of the runnable respect the specification of the XML file, and also provide the check if the code of runnable meets the call of the RT function as specified in the constraint. Yeah, that is how this Polyspace for Autosar kind of analysis also works. Yeah.